Welcome and thanks for joining this session. This is called Spring Forward, Fall Back, How to Use MongoDB Effectively in the Spring Framework. John Ward is a senior solutions architect. He's in Austin with me. He started his career programming software for concert and special effects automation systems. He's been a full stack developer in Java and the Spring platform for various verticals such as banking, healthcare, security, telecommunications, BPM, and government. He got involved early in the open source Eclipse BIRT project early on, consulting and specializing in report development with the Eclipse-based platform and integrations of the Java-based reporting engine. And he's currently the head of the Eclipse BIRT project. He's been an evangelist for lots of technologies, and he spoke at several conventions over the last 15 years. So I met John personally for the first time a couple weeks ago. We're at the Confluent Current conference in Austin a couple of weeks ago, and we actually I'm telling him a story about a magician, and he was kind of really engaged in my story about magicians and Steve Martin being a magician. And I thought, well, he's a really good sport for indulging me like this. And then we ran out of swag. So this is an unofficial bio. And then we ran out of swag early. And then he breaks out all these magic tricks. And then for the rest of the conference, like a whole day, he had a little table here and he was doing magic tricks for everyone. Right when you come in the Austin Convention Center, and they're like, wow, you guys hired a magician? And I'm like, well, yeah, not as a magician, but he's doing his magic tricks. So with that, let's start it off and see if he'll do a magic trick for you guys.
Hey, how's it going, everybody? Come on. Round of applause for Karen for that beautiful intro. Hey, so is everybody enjoying the conference so far today? All right, perfect. Well, I'll tell you what, we are going to get started here. I think they have twisted my arm. I may do a little magic effect here to kind of kick off today's presentation. Very simple one. We got to do this quick because time is short. So I'm going to go ahead and I'm going to tell you guys a story about the first trick that I ever learned. Very simple, and it started like this. As a little kid, I went to a magic show, and I saw the most amazing magic trick where a magician took 1, 2, 3, 4, 5, 6 cards. That's right, a magician took 1, 2, 3, 4, 5, 6 cards. That magician then took 2 cards, threw them away, and he still had 1, 2, 3, 4, 5, 6 cards. That's right, the magician took out 2 cards, and he still had 1, 2, 3, 4, 5, 6 cards. Now, much like you as a little kid, I was so awestruck that I forgot to applaud. Thank you. So, once I was done applauding, the first thing I did was go down to a magic shop, and I said, Mister, I saw the most amazing magic trick last night where a magician, he took out 1, 2, 3, 4, 5, 6 cards. That magician took out 2 cards, and then he still had 1, 2, 3, 4, 5, 6 cards. Do you have that trick? The guy said, no, we don't have a trick where you could take 1, 2, 3, 4, 5, 6 cards, take out 2 cards, and still have 1, 2, 3, 4, 5, 6 cards. No, I have this trick right here where you can take 1, 2, 3, 4, 5, 6 cards, take out 2 cards, and still have 1, 2, 3, 4, 5, 6 cards. So I figured I would kick off this presentation with the magic trick that I learned, where a magician could take 1, 2, 3, 4, 5, 6 cards, take out 2 cards, and still have 1, 2, 3, 4, 5, 6 cards. That's great. Thank you for such a lovely introduction. So hopefully I got everybody riled up, ready to go. So we are going to talk about Spring Data, working with Spring Data and Mongo in a presentation entitled Spring Forward Fallback. We're going to go through this rocket fast. This is such a vast and complicated topic that we could probably write whole books about it and spend days talking about it. So what I had to do was shorten this down significantly. Now, what we're going to be talking about is a couple things. We'll kind of do the TLDR version of the intro here and say, look, we all know Spring, right? Everybody here is familiar with Spring? Funny thing about this is the original version of this presentation, as it was given, the original author said, hey, Spring is the most widely used application development framework for Java, and then said, but I don't have any numbers to verify that, so I don't know if that's a true statement. I read that and said, I am not going up there and saying that, so I did actually validate this. Yes, Spring is indeed the most used application development platform for Java, followed by things like struts and grails, and surprisingly, even Gwt was still on there. I was a little disheartened that Eclipse was not listed in any of the sites that I referenced. Considering that I am the head of the Eclipse BERT project, that was a little interesting. Now, most people, and this has been my experience, as well as the experience of the original author of this presentation, once they get into Spring, they want to work with Spring data. They want to do some kind of data stuff. And in particular, for the topic of this talk, we are seeing more and more people get interested in using MongoDB with Spring. Now, MongoDB is not like other databases. Who here does not know that this is not a relational database? I should not see any hands. Yes, no, it is not a relational database. It is a document database. It is a NoSQL database. Therefore, there are a lot of different considerations we need to take, some of them good, some of them bad, when we work with Spring. So, the agenda for today's talk is we will not be doing an introduction to Spring. That would be a very long talk if we did that. We're going to jump into just a few little issues that you run into when you work with Spring. Particularly, how do you choose which driver, which way you work? How do you use Spring data if you want to do it that way? How do you use the native MongoDB driver if you want to do it that way? How do we work with hash maps in the BSON document model? And then we picked one particular issue that we kind of see a little bit more often than not, and that is working with pagination. So, a tale of two drivers. Now, Spring, when you work with it and you say, hey, I want to go ahead and get into using MongoDB with Spring, your first instinct is probably to jump right in and look for a Spring data module for this. You'll go in, you'll say, hey, I want to go ahead and throw in a quick Maven dependency. I'm going to go ahead and create some entities that are going to be my POJOs for working with stuff for my application logic, and then I'll probably use something like a repository or template for doing querying. It may look something like this. Your Maven dependencies. Hey, I'm going to go ahead and include Spring data, and I'm going to include the Spring data MongoDB driver. Then I'm going to create an entity, something that may look like this. In this case, I'm using the sample database. If you are familiar with our Atlas offering, we have this under our Airbnb offering. So we may see something like this, standard POJO, getters, setters, got to have an ID in there. You may use repositories or templates, very cool, because gives us most of our CRUD operations, inserts, updates, deletes, things like that. One thing I will say is we kind of prefer templates over repositories because templates give you a little bit more flexibility. It also gives you things like our insert many and update many and delete many, whereas a repository typically will give you just insert, update, deletes. But if we have custom business logic, we can write functions for it. We can write queries inside of our functions. We can do things like annotations with a query annotation and write aggregation pipelines and find statements and whatever we want to do to create that custom logic that goes beyond our standard CRUD operations. Now, the typical rule of thumb that we like to give is let's not use Spring data. Let's actually use the native MongoDB driver. Now, the reason for this is, number one, it's always on cutting edge. We always have the most up-to-date version with most of the up-to-date features. Protocol, we don't really change the protocol very often, but any kind of new features like, support for time series collections or something like that, we'll always have that in our drivers. Now, we have a very slightly different design paradigm for how we prefer to work with data, whereas instead of going through and serializing, deserializing, into POJOs, we like to put things into hash maps. Now, this is, if you're a Python developer, very similar to the concept of a dictionary. Hey, I'm just going to have a bunch of KV pairs, key value pairs. I want to look up something, and those values could be your standard primitives, things like integers and strings and dates and stuff like that. But it could also be sub-objects, sub-arrays, sub-hash maps. And the cool thing about this is we can look this up by keys, and it doesn't matter if we change anything. Now, this is very different from Spring Data. We can do strictly typed entity POJO-based stuff with the MongoDB driver using something called a codec. We register a codec and say, hey, I need to be able to serialize and deserialize this into an object in Java. And it's there, and it's cool. It may look something like this. Here is my Maven dependency. Do I actually have a laser pointer? I do not, that I see. Oh, I see the, we're gonna try this. Yay, I do, and that is dim. That is very dim. So yeah, no, we have, we are including our legacy driver here. We're including our core driver. We're including our sync. So all the stuff that we would need for our Mongo driver if we're doing legacy versions, not something you'll include very often, but things like our core and our driver sync, you'll want to include those. You'll also want to include probably the MongoDB bson module as well. So those are kind of the key dependencies you would have when working with MongoDB. What would your driver and connection look like? Well, connection should be pretty straightforward. Hey, I'm going to establish a connection to the database. I create a client. I then come here and say, get database, get collection, and make sure that we are creating bson documents to drop those into. Then I can do any kind of query, whatever I want to do. Hey, I'm doing a find. In this case, I'm using the object notation where I'm creating an equal object and passing that as a parameter with last name Smith. We can do this whether we use strings or whatever. And then we serialize it, return it as a string. Very simple. It's cool. Now, we could do a codec, serialize it into something like, a POJO, but we're not going to do that for today's discussion. I just want to show that it's possible with the native Mongo driver. It's not mutually exclusive. You don't have to say, well, I've been doing Hibernate or Spring Data or, whatever kind of ORM technology I've been using for the past 15, 20 years. I'm so used to it, I want to do it that way. I might have a good architectural reason for doing that. So you do have that option with the Mongo driver. So that brings up the question, when would you want to map to a POJO, and when would you want to use the native hash map? So let's say we have a simple document here. Hey, I've got a single field with 1, 2, 3 in it. I'm going to go ahead and create a class that represents that, my simple POJO, that has a private integer. It has a couple getters and setters. Hey, I want to go ahead and execute a query to find that. In this case, I'm going to just dump it into the simple document class, and then I'm going to output that. And then I can treat it just like any other object in Java, right? That's how we've all been doing this for the better part of, 15, 20 years using ORM technology. Now, what happens if we want to do this with a hash map method? If we're using Mongo's native driver, well, we're going to change the way we do that call a little bit. We're going to execute the same template find, but instead of passing in a class to serialize to for a simple document, we're going to say, hey, let's return it as an org bson document, which is essentially a giant hash map. That's all you need to remember. Documents are basically hash maps in Java. You can look up keys and values. There are other, inherited methods and things like that, but it's very simple to work with, and we can see the difference between the two methods here. We have, hey, get, which will be the first element here, and then we're looking up a key as opposed to get a, which would be our getter. So that looks pretty, pretty one-to-one, right? Simple document, one-to-one. Why would I want to do that? What happens when the document gets more complex? Well, then we have this little nugget right here, where we have a nested array with sub-objects. That becomes very complicated. All right, well, now our simple integer a is no longer an a, it is now an array list. It is now, we have to implement logic for adding to the array list. In this case, we're just saying, hey, pass me an array list, but what if we want to do appends or something like that? We have to add the logic for that. As opposed, here we are, we actually taking this, we're serializing it. As opposed to with the bson method, we don't have to do that. We could just say, hey, I'm just still taking it a document, it's still a hash map, and I'm still looking up things by keys and values. Or still looking up by keys and getting back values. So much simpler to work with, especially if we, change the schema underneath the database. Then we don't have to go in and modify a POJO, modify our getters and setters and all that. We're just accessing key value pairs, so it's much simpler to work with. So, when is this mapping via POJOs useful? If we're trying to enforce strong data typing, Who here has been a developer since they were kids and is used to strongly typed languages like C, C++, Java, things like that? Show of hands. All right, good show of hands. We're used to strongly typed languages. I started off as a functional procedural programmer with Pascal and languages like that. So that's the way that I like to think. I may want to enforce at the application layer some strong typing. I want to implement easy business logic. When I first started learning OOAD, object-oriented analysis and design, I got very used to working with this object notation and calling getters and setters and methods and things like that. So maybe I want to enforce that business logic in that notation that I'm familiar with. But the main reason most people stick with that is because they're using a relational database. And that's just what they know. So when is this not so useful? When we have a data structure that is going to change. We want to have weak typing. We don't always know that A is going to be an integer. A could be a string, it could be a date, it could be a sub-object, or it could not be there at all. That's when having a hash map is very useful. So weak typing is one example. So let's say we use this example schema. Here we have an email. This is the way we've been doing this with our application. All of a sudden a change comes in and people now have multiple email addresses. Okay, great. We have to go in and change our POJO. We have to change our data structures underneath in a relational database, go back to our DBA, stuff like that. All sorts of changes go into play. With Mongo, we don't have to do that. Mongo has a flexible data structure underneath, so then in our application, we don't have to go in and change this. We could just say, hey, I've been looking up email, so let me go ahead and continue to look up in my hash map my email key, and I'll get back an array this time instead of a string. Oh, look, we have version 3 of our schema that's come through. Now, instead of just having an array, we have a sub-object that can have multiple fields. Work, home, it could be other key value pairs. I mean, we could change this evolution of the schema a lot of times. The great thing about using the BSON document type and not going with strictly typed POJOs in Spring is the fact that we can adapt to this very easily. We can implement a schema design pattern, or versioning pattern, sorry, and be able to handle this in a very evolving way. Second reason, when is this not so useful? If you don't even look at the data. So this is a use case that I'm very familiar with because I've done a lot of server-side development. I've done a lot of batch development. I've done my fair share of client-server, UI type stuff as well, but most of the stuff I do is on the back end, and in which case, I don't even need to look at the data. I don't need my application to look at the data. I don't have users looking at the data. I'm just processing the data in some sort of way, right? Why would I go through all of the effort of serializing it, deserializing it, turning it into a document, turning that into a POJO, if I'm just going to reserialize it out to my clients anyway, right? Maybe I just need to do a few calculations. What's the point of going ahead and going through the entire conversion process? Why wouldn't I just go straight out? And that's when another reason why you may just want to use the document model for that. Just use the BSON document type as a hash map, because then I don't have to worry about converting it to POJOs and then back into a serialized form. Finally, performance. And these two actually tie together. So let's say that we are executing a batch process. Now, if we are working with something that has, cross-country, latency issues, something like that, hey, I've got a data center in the West Coast, a data center at the East Coast. My query is very simple, very complex, whatever. It's very complex, it's across country. My performance issues are not necessarily going to be around deserialization. So in that case, it's not really that much of a concern, right? What happens when I'm actually working in a local data center, or I'm working on a laptop, or home network, whatever, and my query is actually very simple? Now, these things should execute very fast. As this starts to aggregate, let's say we start doing hundreds of thousands, millions of queries, that deserialization cost is now taking up a bulk of my processing. That's where we'd want to reduce that. Now, hey, John, that's a bold claim. Can you back it up with numbers? Yes, we quantified this. So here is the simple cost, right? Hey, I've got a local laptop simple query. I don't really see a whole lot of change, right? Nothing big, nothing major. But what happens when we start working with complex queries, complex documents, and we don't have to worry about that network latency? Uh-oh, we start running millions of queries. In this case, 100,000 queries. We start seeing some significant performance decreases. So we look at our first column here. This is executing with the raw method, going into BSIN documents, right? I don't have to serialize in the POJOs. Now, if I am mapping that into POJOs, we can see particularly these last three right here, we are starting to see some significant performance degradations. That is something, if I'm running a batch process, that I have an SLA that I need to meet, in which, in most cases, batch processes that are doing things like, massive calculations that have to be finished in an 8-hour window are doing, this kind of performance becomes unacceptable. We might miss our SLA, and that cannot happen. So that's where we would say, okay, let's not use Spring data. Let's not serialize and deserialize. Let's just go straight into the BSIN document. And then we will work with things as a key value pair. So deserialization cost gets important. The simpler your query is, the closer you are to your server, the more documents that you are returning, and the larger those documents are. Spring developers are working to make this actually a much more efficient process, but it is still an ongoing thing. You know how bug fixes take a little bit to do? Well, we're kind of working at the speed of development there. Now, the last thing I kind of want to talk about is pagination. Now, as a server-side developer, pagination was something that I don't normally deal with, but people that are working with more complex applications are working with building maybe things like REST services that are serving a mobile application or an e-commerce application, something like that. This does become a huge concern. So, batch processing in Spring, let's go ahead and simplify this. Hey, I'm going to go ahead and step through results, right? Let's say I'm looking at page 1 of 100. I need results 1 through 10, and then 10 through 20, and then 20 through 30, so on and so forth. So in this case, we're showing an example of chunking this into batches of 1,000 instead of 10. But the same kind of logic applies. Well, what happens is Spring data, by its default nature, uses a design pattern called skip limiting, which means I'm using an application. I'm on the home page. I'm looking at page 1. No big deal. My limit is set to 10 or 100 or 1,000. I'm going to get those 1,000 results. Hey, no big deal with performance, right? I go to page 2. Oops, I got to skip the next 1,000. Page 3. Oops, I got to skip the next 2,000. 4,000, 5,000, 6,000. We get up to 10,000, and I'm still limiting by 1,000, right? Well, this happens with every page I go to. So I still have to get those first 11,000, skip over all of those, and then limit to my next 1,000 results. This becomes very, very expensive from a performance perspective. Skip limits performance is reduced because we are executing the same query over and over again. We're not tracking where we are. We're just saying, hey, we're skipping and limiting. We're continually opening cursors. We're continually running the same query over and over again, only to ignore more and more as the results go through. This starts to slow down the operation the more pages we get into. Now, what is and this is kind of a very elementary thing, but I see this a lot on a lot of e-commerce sites. Pagination without sorting is meaningless, meaning if you are not sorting your results while you're paginating, you are kind of missing the point, because I will go onto a website and I will see the same result repeat on pages 1, 2, 4, 6, and 10, because the results are coming back in an arbitrary order. They're not coming back sorted. So I'm seeing the same results over and over again. So why are they doing pagination? Because they're not giving me results based on relevancy. I'm going to see the same thing over and over. It's kind of meaningless. So let's say we are then sorting. If you're not indexing on that field, you're executing basically a full collection scan every time. So for 20,000 results, for every 1,000, you're executing a full collection scan 20 times. So what alternatives do we have? How could we fix this? How could we make this a lot more efficient? We've got 5 minutes and 21 seconds. I see it on the clock. All right, number one, we find a way to execute those same queries over and over again, but with a sorted field and remembering where we were. Now, several ways of doing this. We can have an index field for date. Well, we'll get into that in just a second. Second way is that we can keep those cursors that we're working with. As a server-side developer, this one was kind of like, hey, that's what I do anyway. But that's not always something you can do in a stateless environment like with a REST API or something like that. So, option A, remember how far we got. Hey, this is what my skip limit would look like as a query in Mongo, right? Hey, I'm sorting on a date. I'm skipping the, first, 5 pages or 10 pages or 50 pages and limiting by 1,000. I can change that to say, well, why don't I go ahead and index on the date field, remember the last date that was returned for whatever page I was in, and just say, hey, give me everything that's greater than that date and limit it by 1,000. So great, because we can keep this stateless. And all we have to do is remember where the last date was. This could be done at the session level. It could be done at the query level. It could be a URL parameter that gets passed back and forth. Disadvantages, it still needs to run a new query each time. Yes, it's optimized. Yes, it's indexed, but you still need to run a new one. If the sorting is not indexed, queries will still be fatal, but we would index those. Finally, we could reduce a lot of the complexity, especially if we're doing something like an ordered number. We can reduce some of the complexity on that by using something like a materialized view that gets updated. So let's say we're looking at 1 through 10, we're adding another entry for 5. Well, the materialized view can automatically update that stuff. So ways can be done in your design patterns to reduce some of that complexity. Option 2, leave the cursors open. Now, I have a cursor that is open. All I need to do is remember I'm iterating over my result set, and I can pick up on the next page by doing the next has next. Lots of different design patterns for the way that you would handle this. Maybe something like a connection pool, maybe something like a cursor pool. Okay, I have a hash map that is maybe identified by session ID, or maybe is identified by last page number. And then the next client that comes in and says, hey, I want to go ahead and get the next set of pages on that. We're just going to go retrieve that cursor and continue iterating over it. Now, if this is in a stateless environment, like something like a REST service, we can say, okay, well, I don't know what a session ID is. I'm going to go ahead and say last page number or something like that. All right, I'm going to pass that in, and that might be the key for my cursor pool to get the next value. So a couple different ways of migrating that, managing that. We can handle that. If we have to maybe create a new cursor, like, hey, this cursor was open, it retrieved values 1 through 10,000, another process came in, took over that cursor and advanced that, we can create a new cursor, no problem. It doesn't really affect us. RAM is cheap. But there's a lot of things we can do to kind of maybe reduce that. We have to also take into consideration things like limited number of resources. We want to make sure that we don't have too many open cursors, so we have to set things like timeouts and stuff. But that's all things that you can consider and apply to your design. Now, leave cursors open. We have the advantages. Ideally, only one query gets run for your process. Again, let's assume that we're using a session ID and we're opening up a hash map with the cursors. The query only ever gets run once. So, indexed or not indexed, a lot of that performance impact that we would have from repeatedly executing the same queries over and over again is reduced. Cost of sorting is amortized. We can even keep this index. I just said that part. So what about Spring? What does this have to do with Spring, right? This is all some very, low-level design pattern stuff. Guess what? Spring data does open cursors. Everybody clap for that. But stop, because guess what it doesn't do open cursors with? Mongo. That's okay, though. We're working with Spring to get that resolved, where the Mongo item reader will support open cursors in a future version. So we will be able to do the open cursor method. For now, it's doing skip limits. So how do we fix this paging problem? Number one, we avoid skip limits whenever possible. Number two, Spring developers are working on the solution to provide cursors inside of Spring data. we can then say, hey, okay, if I don't have that option, what other options do I have? I can increase my batch size. So instead of maybe doing limits of 1,000, I could do 10,000 or 100,000, and then iterate on those within my application itself. I can make sure my sorts are indexed to reduce a lot of that cost. And to summarize everything with 7 seconds left, Spring is the most widely used application programming framework for Java, verified. Using Spring with MongoDB is a powerful combination. Mapping documents to POJOs may not always be useful or necessary. Beware of skip limit pagination. And that is our session, everybody. Thank you very much. Okay, let's see the left side of the room. Let's see the applause from the left side of the room. That's good. Right side of the room, applause. Left side of the room, you guys are terrible compared to them. You got to do much better. Everybody together. And thank you very much. If you guys have questions, I will be around. We have some other great sessions for the rest of the day. I will be at the Ask the Experts talk booth in just a little bit. So everybody, enjoy your time at the mongodb.local.
Thank you so much, John.